In this video, we're going to talk about how to find the antiderivative of a function. So what is the antiderivative? Well, as the name implies, it is the opposite of differentiation. We know the derivative of f of x is f prime of x. So the antiderivative, or the integral of f prime of x, is f of x. So f of x is the antiderivative of f prime of x, whereas f prime of x is the derivative of f of x. Now the integral, or the antiderivative of regular f of x, is capital F of x. So capital F is the antiderivative of lowercase f, and lowercase f is the antiderivative of f prime of x. So hopefully that gives you a good idea of what the antiderivative is. So let's say if we have the second derivative of a function and we want to find the first derivative, and we can keep going forward in this direction. I just want to give you an overview of these different symbols and functions. So going to the right, we're looking for the antiderivative. Going to the left, we're looking for the derivative. The process of finding the antiderivative is basically integration. The process of finding the derivative is differentiation. So hopefully that summarizes everything that you need to know about this conceptually. Now we said that capital F is the integral of f of x dx. Now you get capital F plus c. You always get a constant of integration, but we're not going to worry about that here. What I'd like to do right now is distinguish what is an indefinite integral versus a definite integral. So this here is what is known as an indefinite integral. An indefinite integral gives you a function, typically in terms of x, but it could be in terms of some other variable like y or z or something like that. A definite integral doesn't give you a function, but it gives you a number. So this is a definite integral. The result of a definite integral is always a number like 20, -8, 45, or something. And you can easily identify or distinguish a definite integral from an indefinite integral. A definite integral has limits of integration. It has a lower limit and an upper limit. An indefinite integral does not have the limits of integration. So that's how you can easily distinguish between them. Now we know that the derivative of x cubed is 3x squared. According to the power rule, the derivative of a variable raised to a constant is the constant times the variable raised to the constant minus 1. Well, the antiderivative of a variable raised to a constant is going to be that variable raised to the constant plus 1 divided by the constant plus 1, and then plus c, the constant of integration. So that's how we could find the antiderivative of a variable raised to a constant. So let's find the antiderivative of 3x squared. So let's rewrite the constant. Now the variable raised to the constant, that's x squared. So what we're going to do is we're going to add 1 to the exponent. So it's going to be 2 plus 1, and then we're going to divide by that result. So it becomes 3x cubed divided by 3. And this gives us the original function x cubed. But we need to add the constant of integration, plus c. If you were to find the derivative of x cubed plus c, x cubed will become 3x squared. The derivative of a constant will become 0. So you end up with the same thing. So always, when you're looking for the indefinite integral of something or the antiderivative, you need to put the constant of integration. The only time you don't need to worry about the constant of integration is if you're finding the definite integral, where you get a number. Besides that, anytime you get a function, add plus c when you're looking for the indefinite integral or the antiderivative. So now let's work on some problems. Go ahead and find the antiderivative of the following functions. Feel free to pause the video and work on these examples. So for the first one, we're just going to add 1 to the exponent. 4 plus 1 is 5. And then we're going to divide by the result and then add the constant of integration. So it's x to the 5th power over 5 plus c. For the next one, it's going to be x to the 8 over 8 plus c. For the next one, it's going to be 6. And then we're going to add 1 to 9. That becomes 10. Divide by 10 plus c. Now this one we can reduce. 6 over 10, if we divide both numbers by 2, that becomes 3 over 5. So we could say this equals 3 over 5 x to the 10 plus c. For the next one, it's going to be 8 x to the 4 over 4 plus c. And we know 8 divided by 4 is 2. So this is 2 x to the 4 plus c. So as you can see, it's not that difficult to find the antiderivative of a function. So go ahead and try this one. Find the antiderivative of, so let's write it this way. Let's say f of x is x cubed minus 4x squared plus 8x. What is the antiderivative, capital F of x, of that function? So go ahead and find the antiderivative f of x. To do that, we're going to find the indefinite integral of x cubed minus 4x squared plus 8x. But just to show our work, let's do it this way first. So the antiderivative is going to be the indefinite integral of f of x dx. So that's the formula. And now let's replace f of x with x cubed minus 4x squared plus 8x dx. So the antiderivative of x cubed is going to be x to the 4 over 4. And then for 4x squared, it's going to be 4x cubed over 3. And then for 8x, it's 8x squared over 2 plus c. Now let's rewrite it. So we're going to rewrite it as 1/4 x to the 4 minus 4 over 3 x cubed. And then 8 over 2 is 4. So we'll write that as 4x squared plus c. So this is the antiderivative of the original function. Now let's try another problem. So let's say f prime of x, that is the first derivative of x, the first derivative of f rather, let's say that's equal to 8x cubed minus 6x squared plus 4x minus 7. So given f prime of x, find the antiderivative f of x. Go ahead and try that. So first, let's write an expression involving indefinite integrals. So we could say that f of x is the indefinite integral of f prime of x dx. So f of x is the antiderivative of f prime of x. So f of x is going to be the indefinite integral of 8x cubed minus 6x squared plus 4x minus 7. Feel free to pause the video if you want to try this. So the antiderivative of x cubed is x to the fourth over 4. For x squared, it's x cubed over 3. And for x to the first power, it's x squared over 2. And then if you have a constant like 7, all you got to do is add an x to it. We'll talk more about that shortly. And then finally, plus c. So now let's simplify our answer. So the antiderivative is going to be 8 divided by 4 is 2, so we have 2x to the fourth power. 6 divided by 3 is also 2. 4 divided by 2 is the same. So this is the antiderivative of our original function. 2x to the fourth power minus 2x cubed plus 2x squared minus 7x plus c. So as you can see, it's not too difficult to find the antiderivative. But there are other things that you need to know. Go ahead and find the indefinite integral of these expressions. Let's make this a z. All right, so go ahead and try those. So let's start with the first one. We want to find the indefinite integral of a constant, 5. And we have dx in front of it. So we know it's going to be 5x. But let's see if we can get the answer using the power rule. 5 is the same as 5 x to the 0. Any variable raised to the 0 power is 1. So x to the 0 is 1 times 5, which is equivalent to 5. Now, using the power rule, this is going to be 5. We're going to add 1 to the exponent and then divide by that result. So the end result is that you get 5x plus c. So whenever you have a constant and you wish to integrate that constant, just add a variable to it. Now the variable that you should add is based on what you see here, either dx, dy, dr, or dz. So what is the indefinite integral of 7 dy? So instead of 7x, this is going to be 7 times y plus c. So the differential, dx, dy, it tells us what variable we should be adding to the constants. The indefinite integral of 8 dr, that's going to be 8 times r plus c. For 6z plus 4, it's going to be 6, and then z to the first power, that becomes z squared over 2. 4 becomes 4z, and then we'll add plus c. So this we could simplify it as 3z squared plus 4z plus c. So that is the indefinite integral of 6z plus 4. Try this problem. So let's say you're given the first derivative of f. And let's say it's 7. This should be not f of x, but f prime of y. So let's say it's 7y cubed minus 3y plus 8. And your goal is to find capital f of y. How would you do it? Feel free to pause the video and try it. So first, let's write a mental outline of what we need to do here. We're given the first derivative of f. need to find f. So f is the antiderivative of f prime, but we're not going to stop there. We need to find capital F. So what we need to do is we need to integrate the function 2 times. So we have a successive integration problem. So first, let's integrate it the first time. Let's find regular f, or little f. So this is going to be the indefinite integral of f prime of y dy. So that is the indefinite integral of 7y cubed minus 3y plus 8. So the antiderivative of y to the third is going to be y to the fourth over 4. The antiderivative of y is y squared over 2. And for the constant 8, it's just going to be 8y based on what we have here, dy. And then plus the constant c. So that's f of y. We don't know what the value of c is. If we were given a point of f of y, we could find c, but we'll save that for another problem. So this here is the general function of f of y. So now let's find capital F of y. That's going to be the indefinite integral of f of y dy. So that is the indefinite integral of 7 over 4 y to the fourth minus 3 over 2 y squared plus 8y plus c as well. And we're going to have dy. So the antiderivative of this, we're going to rewrite the constant, and then we'll find the antiderivative of y to the fourth. So that's going to be y to the fifth over 5, and then minus, let's rewrite the constant first. So we have 3 over 2, and then the antiderivative of y squared is going to be y to the third over 3. And then it's going to be plus 8 times y squared over 2. Now we have the constant of integration c. So we're going to add a y to it. It's going to be c times y, and then plus a new constant, which we'll call d. So this becomes 7 over 20 y to the fifth. Here we can cancel the 3's. So it's going to be minus 1/2 y to the third plus 4 y squared plus cy plus d. So that is the second antiderivative of f prime of y, which is capital F of y. By the way, for those of you who want access to the full-length version of this video, check out the links in the description section below. If you join my YouTube channel membership program, you can get access not only to the full-length version of this video, but many other full-length versions of other videos that I have on YouTube, which you'll see over time. So feel free to take a look at that when you get a chance. Now let's work on finding the indefinite integral of other types of functions. What is the indefinite integral of pi d theta? Feel free to pause the video and work on that. And what is the indefinite integral of e, let's say e ds? So pi is a constant. Let's compare it to the indefinite integral of 7 dy. 7 is a constant, and we would add the variable y to it, so this will be 7y plus c. So pi is a constant, and here we're going to add the variable theta to it, plus c. So that's the indefinite integral of pi d theta. So remember, pi is a constant. It's 3.14 with some other numbers after that. Let me find out what those other numbers are. So it's 3.141592654 with some other numbers. So whenever you see pi, it's just a constant. So treat it as if it's any other number like 7 or 8 or -4. The same is true for e. E is not a variable, it's a constant. E is equal to 2.71828 and so forth. So when looking at a problem like this, E is the constant, S is the variable. So this is going to be E times S plus C. Whenever you're finding the indefinite integral of something, you need to be able to distinguish the constant from the variable in order to integrate it properly. Now let's focus on finding the indefinite integral of rational functions. What is the indefinite integral of 1 over x squared? To find this, before you integrate it, you need to rewrite the expression. We need to move the variable from the bottom to the top. So this is x to the -2. At this point, we could use the power rule. So we can integrate it by adding 1 to the exponent. So it's going to be -2 plus 1, and then dividing by that result, plus c. -2 plus 1, that's -1. And after you integrate it, you need to rewrite it again. So we want to get rid of this negative exponent. And we can do so by moving the variable back to the bottom. So that leaves a 1 on top. And then we're going to have x to the first power on the bottom, which we can just leave as x. The negative sign, I'm going to move it to the top. So the final answer is -1 over x plus c. Now let's try this one. What is the indefinite integral of 1 over x to the 5th power, dx? So feel free to pause the video and try it. So just like before, let's move the variable to the top. So we have the integral of x raised to the -5 dx. And then let's add 1 to that. So -5 plus 1 is -4. And then we're going to divide by that result. Next, let's rewrite the expression. So we're going to move the variable back to the bottom, and the negative sign, we're going to move it to the top. So we're going to have -1. We have a 4 on the bottom, and x, and then this -4 becomes +4, plus c. So -1 over 4x to the 4th plus c. That is the indefinite integral of 1 over x to the 5th power. Try this. Find the indefinite integral of 7 over x cubed dx. So like before, we're going to move the variable to the top. So we're going to rewrite the integral. So this is 7x to the -3 dx. And now let's integrate. So -3 plus 1, that's -2. And then we're going to divide by -2. And then we'll have plus c. So next, we're going to move the variable back to the bottom. And the negative sign, I'm going to move to the top. So this becomes -7. We have a 2 on the bottom. And we have x squared as well. So it's -7 over 2x squared plus c. So that's how you can integrate rational functions. Go ahead and try this expression. Find the indefinite integral of 5x to the 7 minus 9 over x squared plus 4x minus 8 dx. So this is going to be 5x to the 8 over 8. Now for -9x squared, we need to write that as -9x to the -2. So that's going to be -9x, -2 plus 1 is -1, divided by -1. And then for 4x to the first power, that will be 4x squared over 2, and then minus 8x plus c. So we can rewrite this as 5 over 8 x to the 8 plus 9. The two negative signs will cancel, and then we can move the x variable to the bottom. So it's plus, it's plus 9 over x, and then plus 2x squared minus 8x plus c. So that is the indefinite integral, or the antiderivative, of this expression. Now, what is the antiderivative of 1 over x dx? What do you think we need to do here? Well, if we were to try the same approach that we've been using for rational functions, let's say if we were to rewrite the expression by moving x to the top, we would get the indefinite integral of x to the negative 1 dx. Now, using the power rule, if we add 1 to negative 1, we'll get x to the 0. And if we were to divide by that result, we would get something that is undefined. So this technique doesn't work for 1 over x. Instead, this is an integral that you should commit to memory. The integral of 1 over x dx is simply ln x. So you may want to add that to your list of notes. And if you recall, the derivative of ln u, where u is a function of x, is u prime over u. So the derivative of ln x, it's going to be u prime. If u is x, u prime, the derivative of x is 1. So we get 1 over x. So that's the antiderivative of 1 over x to the first power. So if the antiderivative of 1 over x is ln x, what is the antiderivative of 1 over x plus 3? This is simply the natural log of x plus 3. So based on that, go ahead and find the antiderivative of the following expressions. 1 over x minus 5 dx, 5 over x plus 2 dx, and 7 over x plus 4 dx. So this is going to be the natural log of x minus 5 plus c. Now typically, if your answer is like different than ln x, normally you'll see an absolute value around x minus 5. And the reason for this is that you can have a negative number inside the natural log. It's going to be like, it's going to give you an error in the calculator. So typically you'll see an absolute value symbol for expressions that can be negative. For the next one, let's move the constant to the front. So think of this as 5 times the integral of 1 over x plus 2 dx. So this is going to be 5 times the natural log. And let's put our absolute value symbol. So it's 5 ln x plus 2 plus the constant of integration. For the next one, let's do the same thing. Let's move the constant to the front. So this is going to be 7 natural log x plus 4 and then plus c. So that's how you can integrate rational functions where the denominator is a linear function, like x plus 2, x minus 5, and so forth. Now, here's a general formula that you can use when integrating rational functions like 1 over u, where u is a function of x. It's going to be 1 over u prime times the natural log of u plus c. Now, this works if, and this is a big if u is a linear function in the form ax plus b. Now, a could be 0, b could be 0. Well, if a is 0, it doesn't work, but b could be 0. But u has to be a linear function in that form. If there's like an x squared or an x cubed, this formula is not going to work. So let me repeat that. U has to be a linear function. If you have a square root of x or anything but x to the first power, this will not work. So now let's try some harder examples. Based on that, what is the indefinite integral of 1 over 3x plus 4? And let's compare that to the indefinite integral of 1 over x plus 7. So in this case, we can see that u is 3x plus 4. The derivative of u, which is u prime, the derivative of 3x is 3. The derivative of 4 is just nothing. So u prime is 3. So this becomes 1 over 3 ln absolute value 3x plus 4. And then plus c. So this fraction is a result of the derivative of that expression. For the next one, the derivative of x plus 7 is just 1. Here, the derivative of 3x plus 4 is 3. So that's why you gotta incorporate that. So for the next one, u is going to be x plus 7, and u prime is just going to be 1. So this becomes ln absolute value x plus 7 plus c. So knowing that, go ahead and try these two. Oh, by the way, let's go back to what we had before. Let's prove that this is indeed the right answer. So let's find the derivative of 1/3 times ln 3x plus 4. So this is going to be 1 over 3. And keep in mind the derivative of ln x, or ln u rather, is u prime over u. So the u part is what is inside of the natural log function, and so that's 3x plus 4. U prime, the derivative of 3x plus 4, is just 3. And the derivative of c is 0. And so when we cancel the 3's, we're going to start with our original function, which is what we had here. So that shows you that the process works. Go ahead and integrate this expression. Find the indefinite integral of 7 over x plus 4, and also the indefinite integral of 5 over 4x minus 8 dx. Try those two. So for the first one, it's going to be 7 times the indefinite integral of 1 over x plus 4 dx. So it's 7, and the indefinite integral of that expression is going to be the natural log of x plus 4, and then plus c. So that's the answer for the first one. For the second one, let's move the constant to the front. So this is going to be 5 times 1 over u prime. The derivative of 4x minus 8 is 4. So this is going to be times 1 over 4. And then we're going to have the natural log of 4x minus 8. And then plus c. So we can write our final answer as 5 over 4 ln 4x minus 8 plus c. So that's how you can integrate rational functions where the denominator is a linear function but the numerator is a constant. Now let's try one more similar problem. Find the indefinite integral of 9 over 3x minus 7 dx. So remember, the definite integral of 1 over u du is going to be 1 over u prime ln of u plus c if u is a linear function, which it is. 3x minus 7 is a linear function. So first, let's rewrite the constant. We're going to have 9 times u is 3x minus 7. So u prime is going to be 3. So 1 over u prime, that's 1 over 3, times ln of u. And u is the stuff on the bottom. So it's 3x minus 7, and then plus c. So 9 times 1/3, that's going to be 3. Thus the final answer is 3 natural log 3x minus 7 plus c. Now let's focus on integrating radical functions. What is the indefinite integral of the square root of x dx? Go ahead and try that. Whenever you have a radical function, you want to rewrite it. This is x to the first power with an index number of 2. So you can rewrite this as the integral of x to the 1/2. Using the power rule, we need to add 1 to 1/2, and then we need to divide by that result. So what is 1/2 plus 1? 1, we can multiply that by 2 over 2. So we get 1/2 plus 2 over 2, which is 3 over 2. So we have x raised to the 3 over 2 divided by 3 over 2 plus c. Now, when you divide by 3 over 2, it's equivalent to multiplying by 2 over 3. To show that, let's multiply the top and the bottom by 2. 3 over 2 times 2, the 2's will cancel. And so you get 2x to the 3 over 2 over 3 plus c. So the end result is that we multiplied x by 2 over 3, which is the same as dividing it by 3 over 2. And we can leave our answer like this if we want to, or we can convert it back to radical form. So we could say this is 2. Now the index number is still 2, so this is going to be the square root of x cubed over 3. So we can leave our answer like that if we want to. Now let's try the next one. Find the indefinite integral of the 5th root of x to the 4 dx. Go ahead and work on that. So let's begin by rewriting the indefinite integral. So this is going to be x to the 4 over 5 dx. So let's add 1. 4 over 5 plus 1, what is that? To get common denominators, we can multiply the 1 by 5 over 5. And so this becomes 9 over 5. So it's x raised to the 9 over 5 divided by 9 over 5. Now instead of dividing it by 9 over 5, we're going to multiply it by the reciprocal of 9 over 5, which is 5 over 9. And that's what you want to do to save time. Now let's convert our answer back to radical form. We don't have to, but it's optional. So this is 5 over 9, and this is still the 5th root, but instead of x to the 4th, it's going to be x to the 9th plus c. Let's work on a similar problem for the sake of practice. So let's find the indefinite integral of the 7th root of x to the 4 dx. So the first thing is to rewrite it. This is 4 over 7. And then let's integrate it. So let's add 1 to 4 over 7. We're going to multiply this by 7 over 7, which will give us 11 over 7. So it's x raised to the 11 over 7. And instead of dividing it by 11 over 7, just like before, we're going to multiply it by the reciprocal of that, which is 7 over 11. And then finally, let's put it back in radical form. So it's 7 over 11 times the 7th root of x to the 11th plus c. Now let's move on from radical functions to exponential functions. Before we integrate exponential functions, let's talk about the derivative of exponential functions. The derivative of e to the x is e to the x, but let's understand why. The derivative of e to the u, where u is a function of x, is e to the u times u prime. So when u is x, the derivative of x is 1, so we get 1 times e to the x. So using this, if we want to find the derivative of e to the 5x, this would be e to the 5x times the derivative of 5x, which is 5. If we wish to find the derivative of e to the 7x minus 3, this would be e to the 7x minus 3 times the derivative of 7x minus 3, which is 7. And likewise, the derivative of e to the x squared, this is e to the x squared times the derivative of x squared, which is 2x. So that's how we could differentiate exponential functions when the base is e. Now the indefinite integral of e to the u du, this is going to be e to the u over u prime plus c if, once again this is a big if u is a linear function. If u is not a linear function, this doesn't work. You need to use some other technique to integrate it. So let's go ahead and find the antiderivative of the following functions. So the integral of e to the 5x, this is going to be e to the 5x divided by the derivative of 5x, which is 5, plus c. And we can write that as 1 over 5 e to the 5x plus c. So for the next one, it's going to be e to the 8x over 8 plus c, or 1 over 8 e to the 8x plus c. The next one, the derivative of negative 7x is negative 7, so this is going to be negative 1 over 7 e to the negative 7x plus c. Now what about the indefinite integral of e x over 4? So first we need to differentiate x over 4. X over 4 is basically 1/4 times x. The derivative of x is 1. So the derivative of 1/4 times x is just 1/4. So this is going to be e raised to the x over 4 divided by 1 over 4 plus c. Now to get rid of the fraction on the bottom, we can multiply the top and the bottom by 4. So this becomes 4 e to the x over 4. 4 times 1/4 is just 1 plus c. So this is the final answer. Now let's try some more problems. Find the indefinite integral of e raised to the 5x plus 4 dx, and also e raised to the 7 minus 3x dx. So go ahead and try those. So this is going to be e to the 5x plus 4, and then it's going to be divided by. Now the derivative of 5x plus 4, that's simply just 5. So we'll write our final answer as 1 over 5 e to the 5x plus 4 plus c. For the next one, the derivative of 7 minus 3x, that's going to be negative 3. So we can write this as negative 1 over 3 e to the 7 minus 3x plus c. So that's a simple way in which you can integrate exponential functions with the base e if u is a linear function. If we were to try to integrate e to the x squared, it will not equal e to the x squared divided by the derivative of x squared, which is 2x. It's not going to equal that. If you were to find the derivative of this expression, you would have to use the quotient rule. And you're not going to get the original expression e to the x squared. You're going to get something else. This might be part of the answer, but there's going to be other stuff with it. So remember, the reason why this doesn't work is because u, which is x squared in this case, is not a linear function. In this case, it's a quadratic function. So that's why it doesn't work. It only works if u is a linear function. Now what happens if we want to integrate an exponential function where the base is not e? Well, let's talk about that. So first, let's go back to derivatives. We know the derivative of a constant raised to a variable where the base is e is e to u times u prime. So if we have a constant that is not e, it's going to be a to the u times u prime, but times ln a. This is also times ln e, but ln e is 1, so we don't need to write it. So this is the general formula that you'll get if you're differentiating a constant with respect to a variable. So for instance, let's say if we want to find the derivative of 7 raised to the 4x. So a is 7, u is 4x. So it's going to be a to the u. Let's put the equal sign first. So it's a to the u, which is the original expression, times u prime. U prime is, well, u is 4x, so u prime is the derivative of 4x, which is 4, times ln a. A is 7, so this is ln 7. That's how you can differentiate 7 raised to the 4x. Let's try another example. Let's say we want to find the derivative of 3 raised to the x squared minus 6x. So it's a to the u, which is the same thing, 3x squared, 3 raised to the x squared minus 6x, times the derivative of u. The derivative of x squared minus 6x is 2x minus 6, and then times ln a, and a is 3. So that's the derivative of this expression. Now we said that the indefinite integral of e to the u du is e to the u over u prime plus c. Well, the antiderivative of a to the u du is going to be a to the u divided by u prime, but times ln a plus c. So that's the difference. So knowing that, let's find the indefinite integral of 5 raised to the 4x. By the way, this only works if u is a linear function. So this is going to be a to the u, which is 5 raised to the 4x, divided by u prime. The derivative of 4x is 4, and then times ln a, where a is 5. So this is the answer. Let's try another one. Let's find the indefinite integral of 8 raised to the 3 minus 4x. So it's going to be the same thing, 8 raised to the 3 minus 4x, divided by The derivative of 3 minus 4x is negative 4, and then times ln a is 8, plus c. Let's try some more problems. Go ahead and try these two. 5 times 3 raised to the 4x plus 1 dx, and also let's say 7 raised to the 3y over 9 dy. So for this, it's going to be the constant times a to the u. A is 3, u is 4x plus 1. So it really helps to identify what a and u are. So this is a, and this is u. And then u prime is going to be the derivative of 4x plus 1, which is 4, times ln a, or ln 3, and then plus c. So that's the answer for that one. For the next one, let's write everything out. So a is 7, u is 3y, u prime is going to be 3. In this case, u is a function of y. So using the formula, we have 1 over 9, which is the constant, times a to the u. So a is 7, u is 3y, divided by u prime. U prime is 3, and then ln a is 7. So this is equal to, we can multiply 9 and 3, which will give us 27. So we have 7 raised to the 3y divided by 27 natural log of 7 plus c. So that's our final answer. So just to be on the safe side, sometimes it helps to write everything out instead of doing it mentally. Now let's move on to trigonometric functions. If you recall, the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. Well, the opposite is true for the integral. The antiderivative of cosine x is sine x. You may want to write this down in your list of notes because we're going to use this later on in the video. And the integral of sine x, this is negative cosine x plus c. So make sure to write these down. Now let's talk about some other ones. The derivative of tangent is positive secant squared. The derivative of cotangent of x is negative cosecant squared. Therefore, the antiderivative of secant squared is going to be tangent x plus c. And the antiderivative of cosecant squared, it's going to be negative cotangent x plus c. Now, the derivative of secant x, this is secant x tangent x. And the derivative of cosecant x, this is negative cosecant x cotangent x. Therefore, the antiderivative of secant x tangent x, this is simply secant x plus c. And likewise, the antiderivative of cosecant x cotangent x is just going to be negative cosecant x plus c. Now let's work on some practice problems. So let's find the indefinite integral of 5 cosine x minus 4 secant squared x dx. Go ahead and try that. So this is going to be 5 times the indefinite integral of cosine. And you know what? Let's do this problem step by step. Let's break it up into separate integrals, 2 separate integrals. So the integral of 5 cosine x, I'm going to move the constant to the front. And this is going to be negative 4 integral secant squared. The antiderivative of cosine we know is sine. And the antiderivative of secant squared is tangent. And so this is going to be our answer, 5 sine x minus 4 tangent x plus c. Let's try another one. Find the indefinite integral of 8 cosecant x cotangent x dx. The integral of 8 is just 8x. The integral of cosecant x cotangent x, we know it's negative cosecant x, but we got 2 negative signs, so this is going to be 8x plus cosecant x plus c. Next, we have the integral of 9x cubed plus x over 7 minus 4 cosecant squared x. Now, you can break it up into 3 separate integrals, or you could just integrate it the way it is. As long as you get the right answer and you understand how you got the answer, that's what matters. So let's start with this one. This is going to be 9 times the integral of x cubed, which is x to the 4 over 4. Now, you need to view this as 1 over 7 times x. So this is plus 1 over 7 times the integral of x to the first power, which is x squared over 2. And then minus 4 times the integral of cosecant squared, which is negative cotangent x, and then plus c. So let's clean up our answer. This is 9 over 4, x to the 4th. 7 times 2 is 14. So this is going to be plus 1 over 14 x squared. And then we have 2 negative signs. So this is going to be plus 4 cotangent x plus c. So that's the final answer for this example. Let's move on to the next problem. What is the integral of secant theta times secant theta minus tangent theta d theta? Go ahead and work on that. So what do you recommend that we should do here? We can't integrate it immediately. We need to adjust the expression. We need to distribute secant to secant minus tangent. Secant times secant, that's secant squared. And then secant times negative tan, we could just leave that as negative secant tangent theta. Now let's break this up into 2 separate integrals. So we have the integral of secant squared theta d theta minus the integral of secant theta tangent theta d theta. Now we know what the integral of secant squared is. The integral of secant squared theta is going to be tangent theta, and the integral of secant tangent is simply secant, and then plus c. So that's our answer. It's tangent minus secant plus c. Try this. What is the integral of 4 times 1 plus tangent squared y dy? Now we don't know the integral of tan squared, so we can't really do that with what we know at this point. But 1 plus tan squared is a trigonometric identity. You need to know that sine squared plus cosine squared is 1, but also 1 plus tangent squared is secant squared. Likewise, 1 plus cotangent squared is cosecant squared. So those are some trigonometric Pythagorean identities you need to be familiar with. So we can rewrite this as 4 times the integral of secant squared y dy. Now the antiderivative of secant squared is tangent. So we're going to have 4 tangent y plus c. Now let's move on to our next problem. Find the indefinite integral of sine x over 1 minus sine squared. Now this one might be a little hard to do, but we need to use some trigonometric identities to adjust this expression. So recall that we said that sine squared plus cosine squared is 1. Let's subtract both sides by sine squared. So this gives us cosine squared is 1 minus sine squared. So what we could do is we can replace 1 minus sine squared with cosine squared. Now cosine squared, we can break that up into cosine times cosine. So we can have 1 over cosine times sine over cosine. Now the reason why we want to break it up like this is because it's going to work out nicely. 1 over cosine is secant. Sine over cosine is equivalent to tangent. And we know what the integral of secant tangent is. This is secant x. So if you need to find the indefinite integral of a function that looks difficult, try using trigonometric identities to adjust the expression into a form that is much easier to integrate. Now, what is the integral of cosine 2x dx? How can we find the answer to that? Now we know that the integral of cosine x is sine x, but the integral of cosine u du, this is going to be sine u divided by u prime plus c, provided, of course, if u is a linear function. If it's not a linear function, you need to use another technique to integrate this. So in this case, u is equal to 2x. U prime is 2. So the antiderivative of cosine 2x is going to be sine 2x divided by the derivative of 2x, which is 2, plus c. So that's the answer for that problem. Now let's try this one. What is the antiderivative of sine 3x minus 5 dx? The antiderivative of sine is negative cosine. Now whatever the angle is, that's going to stay the same. So this is going to be 3x minus 5. And then the derivative of 3x minus 5 is 3. So we're going to divide this by 3, and then plus c. So that's the antiderivative of sine 3x minus 5. Let's try this one. Let's find the antiderivative of secant squared, 7 minus 4x. So we know the antiderivative of secant squared is tangent x. So this is going to be tangent. The angle is going to stay the same, 7 minus 4x, divided by the derivative of 7 minus 4x, which is negative 4 plus c. So that's how you can integrate those types of trigonometric functions. Consider this problem. Let's say we have x squared plus 4x minus 5 all over 3x. How would you find the indefinite integral of that expression? If you have a fraction where you only have one term on the bottom, one of the best things you could do is break it up into smaller fractions. So this is the integral of x squared divided by 3x. So we're going to take each term and divide it by the denominator. And then plus 4x over 3x minus 5 over 3x dx. Now let's simplify it. So x squared over x is just x. So this will become x over 3, which we can write that as 1 over 3 times x. For those of you who don't see it this way. X squared is x times x, and then we have 3 times x. You could cancel an x. That gives you x over 3, which is 1/3 x. So that's how you can visualize it. For the next one, we can cancel the x variables, and we'll just get plus 4 over 3. For the last one, let's move out the constant, and let's leave 1 over x like that. So the integral of x to the first power is going to be x squared over 2. The integral of a constant is just going to be that constant times x. And for the next one, the integral of 1 over x is ln x. So we can write our final answer as 3 times 2 is 6. So this is 1 over 6 x squared plus 4 over 3 times x minus 5 over 3 ln x plus c. So that is the indefinite integral for that expression. Try this one. Find the indefinite integral of 2x minus 3 times 5x plus 4. If you get a problem like this, before you integrate it, you want to FOIL the two binomials. So we have 2x times 5x. That's going to be 10x squared. And then this is 2x times 4, that's 8x. Here we have negative 15x. And then negative 3 times 4 is negative 12. Now let's go ahead and combine like terms. So we can combine these two. 8x minus 15x is negative 7x. And now at this point, we can go ahead and find the antiderivative. The antiderivative of x squared is x cubed over 3. And for x, it's going to be x squared over 2. And then we'll add the x to the constant and plus c. So this is the answer for this problem. Try this one. Now, what do you recommend that we should do for this problem? One thing that we could do is we can expand it. 3y minus 4 squared is 3y minus 4 times 3y minus 4. So like the last problem, we could FOIL. So we have 3y times 3y. That's going to be 9y squared. And then this is going to be negative 12y plus negative 12y. That's going to be negative 24y in total. And then negative 4 times negative 4 is positive 16. Now the antiderivative of y squared is going to be y cubed over 3. For y to the first, it's going to be y squared over 2. And for 16, it's just going to be 16y, and then plus c. So the final answer is 3y cubed minus 12y squared plus 16y plus c. So that's what you need to do if you were to see a problem like this on the test. Let's try this. T cubed times the square root of t dt. For a problem like this, we want to combine it into a single t variable. The square root of t, the index number here is a 2. The square root of t is t to the 1/2. Now, when you're multiplying two variables with common bases, you can add the exponents. For instance, x squared times x cubed is x to the 5th power. 2 plus 3 is 5. So what we can do here is we can add 3.5. So 3 plus 1/2 is 3.5. And 3, we could multiply this by 2 over 2 to get common denominators. So this becomes 7 over 2. So we have t raised to the 7 over 2 dt. Now it's in a form that we can integrate. So 7 over 2 plus 1. That's 7 over 2 plus 2 over 2, which is 9 over 2. And instead of dividing by 9 over 2, we're going to multiply by 2 over 9. So our answer is 2t to the 9 over 2 over 9 plus c. Now we can put that back in radical form. So we can write that as 2 square root t to the 9 over 9 plus c. So we can leave the answer in this form. Sometimes you may have a multiple choice problem where the answer is in a form that is different than these two. Sometimes it may be in a form that's similar to the original problem. In this case, we're going to adjust this. So let me clear this away. T to the 9 over 2. We can write that as t to the 8 over 2 times t to the 1 over 2. 8 over 2 plus 1 over 2 adds up to 9 over 2. Now 8 over 2 is 4, and t to the 1/2, we know that's the square root of t. So we can write our answer as 2 over 9 t to the 4th times the square root of t plus c. So this format is similar to the form of the original problem. Now let's revisit radical functions, particularly the ones with the square root on the bottom of a fraction. What is the antiderivative of 1 over the square root of x? Well, we know the first thing that we need to do is we need to rewrite the radical as a fractional exponent. So that's 1 over x to the 1/2. The second thing we need to do is move the variable to the top. So this becomes the integral of x to the negative 1/2 dx. So now let's add 1 to the exponent. Negative 1/2 plus 1 is positive 1/2. And instead of dividing it by 1/2, we're going to multiply it by 2 over 1, or simply 2. So the answer for this problem is it's equal to 2 times the square root of x plus c. So this problem wasn't too bad. Let's try another one. Let's find the integral of 1 over the cube root of x to the 4th. Go ahead and work on that. So first, let's rewrite the radical as a fractional exponent. So this is x to the 4/3. And then let's move the variable to the top. So this is x to the negative 4 over 3. Now let's use the power rule. So let's add 1 to negative 4 over 3. Let's multiply 1 by 3 over 3. And so this will give us negative 1/3. And then let's divide by negative 1/3, or let's multiply by negative 3/1. So this is negative 3x to the negative 1/3 plus c. Now, let's move the x variable back to the bottom to change the negative exponent to a positive one. And then let's convert this back to a radical. So this is negative 3 cube root of x plus c. Now there's many forms in which we can write our answer, but how do we know which of these forms we should leave our final answer in? Well, it really depends on the test you're taking. If you have a free response problem, you want to pay careful attention to the instructions of the problem. If there were no specific instructions on a free response question, you could leave your answer here, like that. And this is the answer. It's correct. You should receive 4 points for that. Hopefully you have a nice teacher who's going to give you full credit. Now, sometimes the instructions may specify what form you need to put the answer in. It may specify to put it back in radical form, or it may specify to rationalize the denominator, which we haven't done yet. Now, the good thing about a multiple choice problem is the answers in the multiple choice question tells you what format the answer should be in. So if you don't see this answer as a multiple choice answer, you know you got to adjust your answer, either in this form or rationalize the denominator. So let's go ahead and take it a step further. Let's rationalize this denominator. So we need to get rid of the radical on the bottom. We have one x variable inside the square root, or rather the cube root function. To get the x out of the cube root function, we need a total of 3 x variables. We have one, we're missing 2, so we're going to multiply the top and the bottom by the cube root of x squared. So we're going to have negative 3 cube root x squared. On the bottom, we're going to have the cube root of x cubed. The 3's will cancel, and we're just going to get x. Or you can write it this way. The cube root of x cubed is basically x to the 3/3. And 3 divided by 3 is 1. So it simply becomes x. Thus, this is the final answer after rationalizing the denominator. So you need to be able to put the answer in different forms and see which of these answers is in the multiple choice problem. But if you have a free response question with no specific instructions, you could stop at the first form of the answer that we had earlier. Now let's try another problem. Find the indefinite integral of 9 over the 6th root of x to the 7th. So completely simplify your answer and rationalize the denominator, if applicable. So the first thing we're going to do is we're going to rewrite the radical expression in terms of rational exponents. So this is x raised to the 7 over 6. Next, we need to move this to the top. And so we have the integral of 9 x to the negative 7 over 6 dx. Now let's use the power rule. Negative 7 over 6 plus 1, that's negative 7 over 6 plus 6 over 6, which is negative 1 over 6. And then we're going to multiply that by the reciprocal of negative 1 over 6, which is negative 6 over 1. So we get negative 54 x to the negative 1 over 6 plus c. So that is the answer. But let's simplify it. Let's move x back to the bottom. So this is negative 54 over x raised to the 1 over 6 plus c. Now let's convert this into its radical form. So it's negative 54 over the 6th root of x plus c. and this is x to the first power. Now, in order to get rid of the radical on the bottom, in order to rationalize the denominator, we need to multiply the top and the bottom by 6, the 6th root of x to the 5th. This will give us a total of 6 x variables on the bottom, which will get rid of the radical. And let's not forget plus c. So this is going to be negative 54, 6 root of x to the 5th over the 6th root of x to the 6th plus c. 6 divided by 6 is 1, so that will simply become x. Thus the final answer is negative 54, 6 root of x to the 5th over x plus c. That's the final answer. Go ahead and try this problem. Find the indefinite integral of x to the 3/2 minus 4 square root x plus 8 over square root x. And simplify your final answer as much as possible. So before we integrate this expression, let's rewrite everything. X to the 3/2, we don't have to change it. The square root of x, we can write that as x to the 1/2. Now here we have x to the 1/2 on the bottom. When we move it to the top, it's going to be plus 8 times x to the negative 1/2. Now let's find the antiderivative. So 3/2 plus 1 is 5/2, and we're going to multiply that by 2/5. 1/2 plus 1 is 3/2, so we're going to multiply that by 2/3. And negative 1/2 plus 1 is positive 1/2, and so we'll multiply that by 2/1. So the answer that we have is 2/5 x to the 5/2. Here we can multiply 4 and 2 to get 8. So this is 8/3 x to the 3/2. And then 8 times 2 is 16. Now what we can do with this problem, before we convert it back into its radical form, is we can factor. We can take out the GCF. So we could take out a 2 from 2, negative 8, and 16. Now notice that we have a 5 and a 3. To get rid of the fractions, we could take out the multiple of 5 and 3, which will be 15. And from the x variables, we can take out the one with the lowest exponent. That is x to the 1/2. If we factor out this GCF from everything here, what's going to be inside of the bracket? To find out, there's different ways in which we can do this. So we took out a 2 from this term, so that 2 is gone. Now we took out a 5. When you take away 5 from 15, you get a 3. But because those numbers are in the bottom, this 3 will not be in the bottom, it's going to be in the top. And we took out 1/2 from 5/2. 5/2 minus 1/2 is 4/2, which is 2. So we get 3x squared. Another way in which you can confirm this is you could take this term and divide it by the GCF. You should get that. So if we take x to the 5/2 and divide it by x to the 1/2, you got to subtract the exponents. 5/2 minus 1/2 is 4/2, and you get x squared. So that's how we got the x squared part. To get the 3, we need to divide 2/5 by 2/15. So let's use keep, change, flip. Let's keep the first fraction the same. Let's change division to multiplication, and let's flip the second fraction. So this is 2/5. 15, we can write that as 5 times 3. And so we could cancel the 2, and we can cancel a 5, and we get a 3 on top, which is what we have here. So that's how you could show your work to get the stuff inside of the parentheses. So now, what's going to be left over if we take out this GCF from this term? So we took out a 2 from -8. We'll be left with -4. Now, when dealing with the numbers on the bottom, you need to basically think in the reverse way. So imagine taking out a 3 from 15. You'll be left with 5. But that 5 is on top, not on the bottom. Now, taking out 1/2 from 3/2, 3/2 minus 1/2, that's 2/2, which is 1. So we get x to the first power. For the next one, taking out 2 from 16, we'll be left with 8. Now, we took out 15 from nothing that's on the bottom, or you could think of it as a 1 from the bottom. So taking out 1 from 15, you get 15. So this is going to be times 15. Now we completely remove the x to the 1/2, so that's going to be nothing there. And then we have our plus c term. Now, if you want to check your work, you can multiply the GCF by what's inside. Just to make sure you have the right thing. X to the 1/2 times x squared, that's 2.5, which is 5/2. X to the 1/2 times x to the first power, 1 plus a half is 3/2. And then when you multiply x to the half by this, you're going to get the x to the half. Now, in terms of the numbers, if you multiply 2/15 by 3, you get 2/5. So you have 2/15, which is 2/5 times 3. The 3's cancel, you get 2/5. So that confirms the first coefficient. To confirm the second one, we can multiply these. So we have 2/15, which I'm going to write that as 5 times 3, and then times -4 times 5. As you can see, the 5's will cancel. We have 2 times -4, which is -8/3, and so that works out. For the last one, we're going to multiply 2/15 by 8 times 15. So 15 will cancel, we'll get 2 times 8, which is 16. So the numbers that we have above, these numbers are correct. Now, x to the 1/2, let's write that as the square root of x. So we could say this is 2 square root x over 15 times 3x squared minus 20x, and then 8 times 15. 8 times 15 is 120. So it's plus 120 plus c. So this is as far as we can go in terms of simplifying our answer. As you can see, it looks much different than the answer that we had after we integrated the problem. So sometimes you may have to convert your answer into this format. So this is something that you want to learn how to do. Now, what is the integral of 5 over 1 plus x squared? How would you find the antiderivative of 5 over 1 plus x squared? So you need to be familiar with the formulas for inverse trigonometric functions. Here's a common one. The derivative of arctangent of u is u prime over 1 plus u squared. In this case, u is x. U prime is 1. So the derivative of arctangent of x is 1 over 1 plus x squared. So anytime you see this, the integral of 1 over 1 plus x squared, that's equal to arctangent of x. Now this is a formula that you want to commit to memory because you're going to see it quite often as you progress in your calculus course. So for this particular problem, once we recognize what type of form this expression is in, we can easily get the answer. Let's move the 5 to the front. If we do that, then this problem becomes pretty straightforward. It's 5 times arctangent of x plus c. Now let's briefly review how to evaluate definite integrals. Let's say if we want to evaluate the integral from 1 to 2 of x squared dx. So remember, this is an indefinite integral where there's no numbers here, and this will give you a function in terms of x or some other variable. With a definite integral, your final answer will be a number. So first, what we're going to do is we're going to find the antiderivative of x squared, which is x cubed over 3, and then we'll plug in the numbers 1 and 2. So first, we'll plug in the top number 2 into that expression. That's going to be 2 raised to the third over 3, and then we'll plug in 1, the bottom number. So this is 8 over 3 minus 1 over 3, which is 7 over 3. So that's a quick and simple way on how to evaluate definite integrals. Try this one. From 1 to 3, go ahead and integrate this expression. X cubed minus 4x plus 5. So first, let's find the antiderivative. Antiderivative of x cubed is x to the 4 over 4. And for x, it's x squared over 2, and then plus 5x, 1 to 3. When dealing with definite integrals, you don't need to worry about the constant of integration. You don't have to write plus c. C will cancel. So let's begin by plugging in the top number. So this is 3 to the 4 over 4. Now 4 over 2, that's going to reduce to 2. And then it's going to be 3 squared plus 5 times 3. Now let's plug in the bottom number, 1. So it's 1 to the 4th over 4 minus 2 times 1 squared plus 5 times 1. 3 to the 4th power is 81. 3 squared is 9 times 2, that's 18. 5 times 3 is 15. And this is 1/4 minus 2 plus 5. So now we just got to do the math. Negative 18 plus 15 is negative 3. And then we have minus 1/4 because of this negative sign. Negative 2 plus 5 is 3. And then distribute the negative, that's going to be negative 3. That one was not supposed to be there. 81 over 4 minus 1 over 4 is 80 over 4. Negative 3 minus 3 is negative 6, and 80 over 4 is 20, so we have 20 minus 6, which is 14. Now, there are some calculators that you could use where you can just plug in the definite integral to confirm your answer. The one that I like using, it's a regular scientific calculator. It's the Casio FX-115 ES Plus calculator. You can probably find it on eBay or Amazon. But you can easily plug in this definite integral and get the answer. So I'm going to take a second, or a few seconds rather, to do that to make sure my answer is indeed correct. And it is. So it's always good to use a calculator to check your answer when dealing with definite integrals. Let's work on one more. Find the indefinite integral of 1 over x dx from 1 to e. We know the antiderivative of 1 over x is the natural log of x. And so once we plug in the top number, we'll have ln e minus the bottom number, ln 1. ln e is 1, ln 1 is 0, so the final answer is just 1. Now let's work on some problems that look like this. Write a function f of x given that f prime of x is equal to 5x minus 3 and f of 2 is 7. So f of x is the antiderivative of f prime of x. So we're looking for the indefinite integral of 5x minus 3. So let's go ahead and find it. The antiderivative of 5x is going to be 5x squared over 2. And for negative 3, it's negative 3x. but plus c. The only difference between this problem and the other ones is that we have the information that we need to calculate c. F of 2 is 7. So when we plug in 2, this whole thing should equal 7. F of 2, which is going to be 5 times 2 squared over 2 minus 3 over 2, 3 times 2 rather, plus c, all of that should equal 7. So our goal now is to calculate c. 2 squared divided by 2, that's 4 over 2, which is 2. So we get 5 times 2, which is 10, minus 3 times 2, which is 6, and 10 minus 6 is 4. So c is going to be 7 minus 4, therefore c is 3. So now we can write our final answer, now that we know the value of c. So we can say that f of x is 5 over 2 x squared minus 3x plus 3. And so that's all we need to do for this problem. To find f, we just need to find the indefinite integral and solve for c, the constant of integration. Number 2, write a function for y given dy over dx is x squared plus 4 using the point 1, 5. So what we need to realize is that y is equivalent to f of x. Dy over dx is equivalent to f prime of x. So this problem is very similar to the first problem. We're given the first derivative and we need to find the original function. So dy over dx is basically the derivative of y with respect to x. So we have that dy over dx is equal to x squared plus 4. Now what we're going to do now is we're going to separate the variables. We're going to multiply both sides by dx. So this is called separation of variables. And then we're going to find the indefinite integral of both sides. So on the left side, this is basically 1 times dy. On the right side, we have the indefinite integral of x squared plus 4 dx. The indefinite integral of 1 dy is just y. For x squared, it's x cubed over 3. And then we're going to have plus 4x plus c. So now we have the point 1, 5. So we could use that to calculate c. When x is 1, y is 5. So let's replace y with 5 and x with 1. Let's subtract both sides by 4. So these will cancel. 5 minus 4 is 1. So we have 1 is equal to 1/3 plus c. Now to get rid of the fraction, I'm going to multiply everything by 3. So 3 times 1 is 3. 3 times 1/3 is 1. And then we have 3c. Subtracting both sides by 1, 3 minus 1 is 2. And then dividing both sides by 3, I get that c is 2 over 3. So now we can rewrite the original expression. Y is equal to 1/3 x cubed plus 4x plus 2 over 3. And if you want to check your work, you can plug in 1, 5 to make sure you have the right answer. So if we were to plug in 1 into x, we should get 5. So this is 1 over 3 plus 4 plus 2 over 3. 1 over 3 plus 2 over 3, that's 3 over 3, which is 1. And 1 plus 4 is 5. So this works. So this is the function for y in terms of x. Now let's work on number 3. Write a function for f of x if the second derivative, f double prime of x, is 12x squared minus 6x plus 4. And we're given 2 points this time because we need to integrate this twice. We're given a point in the first derivative function and the original function. So let's begin by finding f prime of x, which is the antiderivative of f double prime of x. So this is going to be the indefinite integral of 12x squared minus 6x plus 4. So this is going to be 12x to the third power over 3 minus 6x squared over 2 plus 4x plus c. So thus we could say that f prime of x, let me write this a little bit lower. F prime of x is 4x cubed minus 3x squared plus 4x plus c. So now let's use this point to calculate c. So f prime of 2 is going to be 4 times 2 raised to the third power minus 3 times 2 squared plus 4 times 2 plus c, and f prime of 2 is equal to 27. So we're going to set this to 27. 2 to the third power is 8 times 4, that's 32. 2 squared is 4 times 3 is 12. 4 times 2 is 8. And so we have this right now. (32 minus 12 is 20. And 20 plus 8 is 28. Subtracting both sides by 28, we have 27 minus 28, which is negative 1. So we could say that f prime of x is 4x cubed minus 3x squared plus 4x minus 1. All we need to do is replace c with 1. So this is the answer to the first part of the problem. Now, let's focus on the second part. Let's find f of x. So f of x is going to be the indefinite integral of f prime of x dx. So this is going to be the indefinite integral of 4x cubed minus 3x squared plus 4x minus 1. So this is going to be 4x. We're going to add 1 to that, so that's going to be to the fourth power divided by 4 minus 3x, add 1, so that's going to be to the third power divided by 3 plus 4x to the second power divided by 2. The antiderivative of negative 1 is just going to be negative 1 times x. And then we need a new constant. We've already used the constant c, so let's move on to the next letter, d. Now let's simplify this expression. 4 over 4 is 1, so we have x to the fourth. 3 over 3 is 1, so negative x cubed, and then plus 2x squared minus x plus the constant d. So now let's use this point to find the value of d. Let's plug in 1. And f of 1 is 11. So 1 minus 1, that cancels. 2 minus 1 is 1 plus d, which is 11. Well, we know that 1 plus 10 is 11, so d has to be equal to 10. So knowing that d is 10, we can now write our final answer. So the original function, f of x, and I deleted too much stuff. So the original function f of x is going to be x to the fourth minus x cubed plus 2x squared minus x plus 10. So this is the final answer. Number 4. The acceleration of a particle when t, let's say it's equal to or greater than 0, is described by the function a of t is equal to 6t minus 12. Part A. Write a function v of t that describes the velocity of the particle, given that v of 0 is 4. So we have the acceleration function, which is 6t minus 12, and we know that v of 0 is 4. What is v of t? So first, we need to understand the relationship between acceleration, velocity, and position. As we go to the right, we are finding the antiderivative. The process of going to the right is integration, which involves finding the antiderivative. The process where we're going to the left, this is differentiation, where we need to find the derivative. So this chapter, or this video, is about antiderivatives, so we're going to focus on the integration aspect. We're given acceleration, we need to integrate to get velocity, and then integrate velocity to get position. So thus we can say that the velocity function is the antiderivative of the acceleration function. So this is going to be the antiderivative, or the indefinite integral, of 6t minus 12 dt. The antiderivative of 6t is 6t squared over 2, and then this is going to be minus 12t plus c. So that's 3t squared minus 12t plus c. So now let's use this point to get the value of c. So v of 0, which is 3 times 0 squared minus 12 times 0 plus c, that's equal to 4. Well, this is 0, so therefore c has to be equal to 4. So we could say that v of t is 3t squared minus 12t, and then we're going to replace c with 4. So that's the velocity function. That's the answer for part A. Now let's move on to part B. Write a function s of t that describes the position of the particle at any time t, given that s of 2 is equal to 4. So the position function is the antiderivative of the velocity function. So we need to integrate 3t squared minus 12t plus 4. So this is going to be 3t to the third power over 3, which is just t to the third power. This is going to be negative 12t squared over 2, which is negative 6t squared. And then it's going to be plus 4t, and then plus the new constant of integration, d. So now let's plug in this information. S of 2, let's replace t with 2. And all of this will equal 4. 2 to the third power is 8. 2 squared is 4 times 6, that's 24. 4 times 2 is 8. 8 plus 8 is 16. 16 minus 24, that's going to be negative 8. So we have negative 8 plus d is 4. And so we're going to add 8 to both sides. And this will give us that d is 12. So we could say that s of t is going to be t to the third power minus 6t squared plus 4t, and then plus 12. Number 5. The graph of f is shown below. Make a rough sketch of the antiderivative function, capital F. So how can we do this? When sketching the antiderivative, you need to think in terms of accumulation and deaccumulation. So when the graph of f is above the x-axis, the area is positive. The area under the curve is equal to the definite integral from a to b of f of x dx. So the value of the antiderivative function f changes based on the area under the curve. So when the area is positive, f of x is going to go up. When the area is negative, f of x is going to go down. So between 0 and 2, the area is positive, so this function is going to increase. Between 2 to 4, the area is negative, so it's going to decrease. It's not necessarily going to be below the x-axis. It's just during this region, it's going to decrease. Now from 4 to 6, we have a positive area, so it's going to increase. In order to determine if it's going to be above or below the x-axis, we need to look at the relative amount of area between those 2 points. So let's assume that we're started from the origin. Let's use a different color. Notice that the area from 0 to 2 and 2 to 4, they're about the same. So when it rises from 0 to 2, it's going to go back down to the x-axis from 2 to 4. If this area was larger than the area from 0 to 2, then it would go below the x-axis. But since they're about the same, the amount gained from 0 to 2 in its accumulation phase is going to equal the amount lost from 2 to 4 in the deaccumulation phase. Now there's something else that you need to know, and that is that the slope of the antiderivative function is equal to the y value of the original function. So when the y value of lowercase f is 0, or on the x-axis, what we have is a horizontal tangent. So at 0, 2, and 4, the slope is 0. So here, this is going to be a horizontal tangent. At 2, we're going to have a horizontal tangent, and at 4, we'll have a horizontal tangent. At this point, f has the highest y value. So around 1, the slope of f, of capital F, will be the greatest. So at 1, we're going to have the steepest line. Here, the y value has its largest negative value. So we're going to have the hugest or the most steepest negative slope at 3. So the slope of the antiderivative function correlates to the y value of the original function. So when the area is positive, capital F, or the antiderivative function, will be in the accumulation phase. So it's going to increase like that. So as we can see here, we have the maximum slope, and then it's going to decrease. So at this point, the slope is going to be most negative, and then it's going to go back to 0, where we have a horizontal tangent. So we're assuming that these two are equal in magnitude, but opposite in sign, so therefore it goes back to 0. Now the area is once again positive, and it doesn't return back to 0. Therefore, this will continue to increase. And the rate of increase is based on the area under the curve and the y value. So remember, here the y value is the greatest. So at this point, that's when the slope will be at the highest. So the slope is going to rise, and then it's going to continue to increase, but it's not going to be as steep anymore. So the slope is going to decrease, Here, the y value is relatively constant, so the slope is going to be relatively constant. So it's going to keep increasing, but at a constant rate. So that's how we can sketch the antiderivative f from lowercase f. So here we have a local max in terms of y value, and so here we have a local max in terms of slope value.